So the first thing I want to remind you about synthetic division is it can replace long division, but only when the thing we're dividing by is a first degree polynomial. So this has to be a linear polynomial. If this was an x squared plus 4 instead, we would not be able to use synthetic division for it. So it's not the fact that it's a binomial, it has to be a first degree polynomial. Synthetic division only works in that case. So if that had been x squared plus 4, we'd be forced to go back and do this using long division instead. All right, so here's how this works. Synthetic division, we're always going to have a box. So let me get this set up here. There's going to be a box here, and then there's going to be some coefficients. These are the coefficients of my numerator. So 3, 21, 38, and 6. And the thing that goes inside of the box is the 0 of your denominator. You guys remember how to find the 0 of something? Set it equal to 0 and solve. So if I set x plus 4 equal to 0 and solve, I'm going to get negative 4. That's my multiplier. Every time I multiply in this problem, I'm going to be multiplying by negative 4. And then we leave space for a second row underneath that. We draw a line. And then, were you guys used to leaving a box here for the remainder also? No? Okay, I like to draw a little box here to separate my remainder. Whatever ends up in this box at the end is going to be my remainder. The process for synthetic division just goes like this. We add going straight down. And then we multiply going up diagonally. And then we just repeat. Add going down, multiply up diagonally. And whenever we multiply, we will always multiply by the same thing. We'll be multiplying by our multiplier, the thing in our box here. All right, so let's do this. So we always start adding. The first time we add, there's nothing to add. 3 plus 0 is just 3. And then I'm going to take that 3 and I'm going to multiply it. I usually don't draw these arrows. I'm just doing it for the sake of our notes. And anytime we multiply, we always multiply by the same thing. By this, in this case, a negative 4. So 3 times negative 4 gets us negative 12. And then we just rinse and repeat until we don't have anything left to do. So keep adding down. 21 plus negative 12 gets us positive 9. And then multiply up diagonally here. 9 times negative 4 gets us negative 36. Add going down. 38 plus negative 36 gets us 2. Multiply going up diagonally. 2 times negative 4 gets us negative 8. And adding one more time to get our remainder of negative 2. Is this coming back? Or maybe it never left. Then we just have to translate that into our final answer and we're done. So the thing in the box will always be a remainder, and then from there we go to the right, we start with our constant term. That's going to be our constant term. This is going to be our x term. This will be our x squared term. X to the third, if we had another, we would just build on x's after that. So my final answer is going to be 3x to the second plus 9x, because that's a positive 9, plus 2, that's my constant, plus, and then our remainder always goes on top of the thing we're dividing by, which is x plus 4, and my remainder was negative 2. And that's it. And again, make sure that when you're practicing these, that you are writing your answers in this format. That's going to become important to us when we start using this to find our oblique and nonlinear asymptotes. That's it. Any questions? Is this pretty much the same way you learned last year? Except you guys didn't use this box. You just knew that the last thing was going to go in your remainder? Okay. All right, should we do another one? This next one's tricky. As you're writing it down, see if you can spot what's tricky about it. This is probably, other than just making silly sign mistakes, which we all make from time to time, this is probably the trickiest thing about synthetic division. If there's something you got to remember to do, it's really easy to forget. And if you forget it, you're going to get the wrong answer. Are you seeing it? Are you guys seeing what's kind of, what do I need to what do I need to notice before I start setting my synthetic division up? Yeah, good. You guys noticed it. I'm missing an x squared term. I got x to the fourth, x to the third, but I don't have an x squared term. That's going to mess things up. I need to keep in mind that there is no x squared term, and when I write my coefficients, I have to include that 0. If that 0 is not there, I'm going to get a wrong answer. Are you guys in the habit of doing that when you do long division too? Do you always put your 0x's or your 0x squareds in? It's not strictly necessary for long division, but man, things get really messy if you don't include it. It keeps everything lined up nicely. Synthetic division, it is absolutely necessary. So I'm going to set up my coefficients are 8, negative 72, 0, 6, and negative 50. And again, if I had left that 0 out, I would have gotten an incorrect answer here. All right, find the 0 of this. It's 9. And now I just have to go through and do my add, multiply, add, multiply, add, multiply, add, multiply. So add gets me 8. Multiply gets me 72. Ooh, I like when this happens. When you start getting zeros, yeah. And then you multiply and you keep a 0. Oh, there's some more zeros. Wahoo! Multiply that 0, add that 6. 9 times 6 is 54. That's right, isn't it? I got this wrong earlier today. 9 times 6 is 54, not 56, right? That's embarrassing. All right, and then add, that's 4. When I write out my final answer, I'm not going to put a bunch of zeros in there. So what do I actually need? My constant is 6. This is x, x squared, x to the third. We don't need an x squared or an x. So my final answer is going to be 8x to the third plus 6 plus, and then 4 over x plus 9. It should be minus. Thank you. I just cannot get this problem right today. Something about it. It's been jinxed. At least I got my times tables right this time. All right. This next example, this isn't going to come up too much in our work, but those of you who do the Poly project, which, by the way, that'll get added to Canvas later on this week. It might not be till Friday. But it's not due for like 2 months. Those who do the Poly project are going to run into this. Do you guys know what changes when we're dividing by something that has a coefficient other than 1? So we're going to end up with a fraction in our multiplication box, right? And then do you remember there's like a little extra step that we have to do at the end of the problem? Gus, what's that extra thing we have to do? You remember there is something though. Okay. Well, let me show you how this works. So I'm going to set this up. Leave a little bit of space underneath this for me before you start setting it up. If you're going to do this problem with me, when you go to set it up, leave me some space underneath. I'm not missing anything this time around, so I don't need any zeros. And what's the 0 for 4x minus 3? It would be positive 3 over 4. Does that sound right? Do you guys know the mental trick for multiplying by fractions? There's a little mental trick that makes this much, much easier. Would you like to know? Check this out. This is just off to the side. Forget about this problem for a second. What if I'm multiplying something like 35 and I need to multiply that by 3/5? Can you pull that off in your head really quickly? The answer is 21. Can you guys get that quickly? You want to know how? It's not hard. Okay, check this out. There's two things going on here. Multiplication by 3 and division by 5. Do the division first. What is 35 divided by 5? 7. Now multiply it by 3. 21. That's easy, isn't it? Okay, check this one out. What if I asked you to do 32 times 5/8? Do your division first. What's 32 divided by 4? Oops, sorry. 32 divided by 8 is 4. And then times 5 is 20. See, that's not too hard, is it? If you do the division first and then your multiplication, you're going to end up with an easier way to go, okay? So keep that in mind as we do this problem up here, okay? Now, before I get into all this, I got to explain something to you, okay? Before we do this, and if you've already started, I want you to stop right now, okay? Whatever I get in this row right here is not going to be will not be the coefficients that I want to use, because here's the thing. When you use this synthetic division format, it is always assuming that the lead coefficient on the bottom is a 1. So when you're doing this, what you're actually doing is you are dividing by x minus 3/4. Okay? That's what synthetic division thinks you want to divide by. It's always x minus whatever is in your little box here. Okay, but that's okay. We can fix our final answer because we're not trying to divide by x minus 3/4. We're trying to divide by 4x minus 3. What could I do to this denominator so that it was equal to 4x minus 3? One small change. I could put a number out in front of this thing and multiply it, and it would be 4x minus 3. What's that number that I need to put out there? 4. So here's how I need you to think of it. The synthetic division is going to take care of dividing by x minus 3/4. When we finish that, we also need to go back and manually divide by this 4 here. So whatever I get in that row of coefficients, I'm going to divide it by 4, and now I'm actually doing the division that I want. Does that make sense? That's that extra little thing that we have to do at the end. We need to divide by, and it's going to end up being whatever your denominator is here. Well, it's not true. It's going to be whatever your lead coefficient is here. All right, so let's go ahead and do the synthetic division. Use the little trick. It'll make it easier for you. So 4 drops down. Divide by 4 is 1 times 3 is 3. That's 24. Divide by 4 is 6 times 3 is 18. It's also 24. 4 is 18. Negative 20. 4 is negative 5. It's negative 15. And that's 7. And again, remember, these are the coefficients that you would have gotten if you just divided by the x minus 3/4. But we need to also divide by the 4 that's sitting here. Now the 7 does not get divided by the 4. The remainder stays the remainder. So dividing those coefficients by 4 gets us a 1, 6, 6, and negative 5. And those are going to be the coefficients for my quotient. So x squared, x to the third, 1x to the third, plus 6x squared, plus 6x, minus 5. And then my remainder of 7 over 4x minus 3. All right, any questions? So I didn't put any of these in the practice set. We're not going to run into many where we have a coefficient in front, except for those who choose to do the poly project. All right, remainder of the time is yours. Get some questions answered if you got them. If you have questions over the